I thank all of you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We now discuss the solution of a problem that appeared in the CSIR National Eligibility Test held in the month of June 2023. This question is from the numerical analysis and it is related to the quadrature formula. This question appears in part B, which is a multiple choice question. It carries 3 marks. Its question ID is 704042. Right. The given question is, which of the following values of A, B, C and D will produce a quadrature formula integral -1 to +1 f of x dx approximately equal to a times f of -1 plus b times f of 1 plus c times f prime of -1 plus d times f prime 1 that produce this quadrature formula that has degree of precision 3. So we have to find out the values of A, B, C, D that produce this quadrature formula a degree of precision 3, that is the degree of accuracy 3. We are given 4 options for A, B, C, D values. So these are the options 1 to 4 for the values of A, B, C, D. Right. We now discuss the solution of the problem in detail. Before that, we recall the definition of the degree of precision. Sometimes this is also called the degree of accuracy. It is defined as the degree of accuracy or the degree of precision of a quadrature formula is the largest positive integer n such that the formula is exact for x power k for each k is equal to 0, 1, 2, 3 up to n, and there exists at least one polynomial of degree k plus 1 for which the formula is not exact. So a quadrature formula is said to have the degree of precision or degree of accuracy of degree of accuracy n if the formula is exact for x to the power of k for various values of k is equal to 0, 1 to n, and the formula is not exact for some polynomial of degree k plus 1. There must exist at least one polynomial of degree k plus 1 for which the formula is not exact. Then the formula has the degree of precision n. Right. Now, we have studied several quadrature formulae, and one of them is trapezoidal rule, and this has the degree of precision 1. And the Simpson's 1/3 rule has a degree of precision 3. And so also the Simpson's rule, Simpson's 3/8 rule is also having the degree of precision 3. Remember them, it may help you. Let's now discuss the solution of the problem in detail. We have the quadrature formula. This is the formula what we have. Agreed. And required to find the values of A, B, C, D that gives the degree of precision 3. Therefore, we take to have the degree of precision 3, the quadrature formula is exact for x to the power of k is equal to 0, 1, 2, 3. Thus, we take f of x is equal to 1, x square, x cube. We continue in the next slide. We have the quadrature formula here, in which A, B, C, D are unknowns, and the degree this formula is exact for x to the power of k is equal to 0, 1, 2, 3, because it has a degree of precision 3. So we have to try for f of x is equal to 1, f of x is equal to x, f of x is equal to x square, f of x is equal to x cube. So first step is f of x is equal to 1, then integral minus 1 to plus 1 dx plus a times f of minus 1. F of minus 1 is 1 only. B times f of 1 is 1 only, plus c times f prime of minus 1. Fx is 1, its derivative f prime x is 0. Therefore, f prime minus 1 is 0, f prime 1 is also 0. Thus, you get a plus b is equal to the integral 1 dx is x to be evaluated between the limits minus 1 to plus 1. Evaluate, we will get 2. So, a and b are related like this. Now, second one, f of x is equal to x, f prime x is equal to 1. Then the quadrature formula becomes integral minus 1 to plus 1 x dx, and it becomes exact. That is why we are writing equal to is equal to a times f of minus 1 is minus 1, plus b times f of 1 is 1, plus c times f prime of minus 1 is 1 only, and d times f prime of 1 is 1. Thus, you get the equation minus a plus b plus c plus d is equal to 0. In a similar fashion, f of x is equal to x square, f prime x is equal to 2x, and we substitute the values and evaluate, and we get the equation a plus b minus 2c plus 2d, and the integral of x square is x cubed by 3 to be evaluated between the limits minus 1 to plus 1. You will get the answer 2 by 3. Right. And lastly, f of x is equal to x cube, f prime x is 3x square, and it is exact. So put the values here and get the equation, and we get minus, and when you have taken f of x, integral minus 1 to plus 1 x dx is 0, because it is a polynomial of odd degree. And here also x cube odd degree, and the integral value is 0. So this is the integral value, and they are related like this. Right. That means we got 4 equations and 4 unknowns. They are, that's the first equation, second from here, third from here, and the fourth from here. So we got 4 equations and 4 unknowns, and it is a matter of solving them. Right. So now 4 minus 2, fourth equation minus second equation. If you subtract, then you will get 2c plus 2d is equal to 0, and you will get c plus d is equal to 0. That's the fifth equation. Now 1 and 3 you take. First equation and third equation. In the third equation, put the value of a plus b is equal to 2 and simplify. You will get c minus d is equal to 2 by 3. Thus, we got c plus d is equal to 0, c minus d is equal to 2 by 3, and solve for it. You will get c is equal to 1 by 3, and d is equal to minus 1 by 3. And take the second equation and the fifth equation. So, take the second equation, and the fifth equation is c plus d is equal to 0. Substitute here. You will get minus a plus b is equal to 0. That is a minus b is equal to 0. We already had a plus b is equal to 2. So a plus b is equal to 2, a minus b is equal to 0. Solving a is equal to b is equal to 1. Thus, the solutions for a, b, c, d are a is equal to 1, b is equal to 1, c is equal to 1 by 3, d is equal to minus 1 by 3. And call on the options. And your option 1 is a is 1, b is 1, c is 1 by 3, d is minus 1 by 3. That is precisely our answer. Therefore, the answer to this option 1 is true. The answer to this question is option 1. Right. And that is the detailed discussion of the solution of this problem. But our students say, sir, it is lengthier. It will take more time in the examination. So how do we do? I will show you. How do we save the time in the examination? Go to the next slide. Right, that is the quadrature formula. And we have to try out for f of x is equal to have the degree of precision 3, we have to get f of x is equal to 1, x square, x cube. Then that will be exact, that is given. So f of x is equal to 1. So these steps I have already talked about. A plus b is equal to 2. Call on the options. In option 1, a plus b is 2, right? In option 2, a plus b is 0. Therefore, option 2 is not true. So also, in option 4, a plus b is 0. But we have a plus b is equal to 2. Therefore, options 2 and 4 are not true. So, go to f of x is equal to x and substitute here. Get the equation minus a plus b plus c plus d is equal to 0. For the values of options 1 and 3, you take these values, substitute in this. This equation is satisfied. Therefore, we can't say anything. So, we go for the next step, f of x is equal to x square, and get the equation. So, the equation is a plus b minus 2c plus 2d is equal to 2 by 3. So, get into the values of option 1 and option 3, whether for these values, whether this equation is satisfied or not, you see. First, we go to option 3. In option 3, a plus b minus 2c plus 2d. So, a plus b, that is 2. Minus 2c plus 2d is 4 by 3. 2 plus 4 by 3 is 10 by 3, but our answer is 2 by 3. Therefore, option 3 is not true. Therefore, leftover is option 1 is true. But anyway, we check. And you take a plus b minus 2c plus 2d. A plus b is 2. Minus 2c plus 2d is minus 4 by 3 for these values. Then you will get a 2 by 3 answer and it tallies with this one. Therefore, the option 1 is true. Option 1 is true and the answer to this question is option 1. That is the detailed discussion of the solution of this problem. And I add a remark here that questions coming from numerical analysis are appearing to be easier to attack in the examination hall, provided you remember formulae and the procedures. So please make some efforts to get into the numerical analysis and prepare good notes for various formulae and the procedures. With these few words, I say, I am sure that you have understood the solution of this problem. Thank you for watching this video now. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. We certainly hope to meet you once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.